So when you walked in this morning, you should have, or yeah, it still is this morning. When you walked in this morning, you should have grabbed a white sheet and one piece of spaghetti. Okay? Try not to destroy your piece of spaghetti yet. We'll get to that here momentarily. Okay? Okay? So before we get to graphing sine and cosine today, let's talk a little bit about sine and cosine and on what they all mean for us and trig functions. Okay? So if we have a trig function, sine, cosine, tangent, cotangent, cosecant, secant, all of those, okay? All of those functions have an angle as its independent variable. Okay. You put in an angle into that. You find the sine of an angle. You find the cosine of an angle. Okay. You find the trig function of an angle, so the independent variable is then going to be your angle. That's your input. What you get out then is you get out some value. Okay? You get out some number. You get a number that comes out of it. The sine of 30 degrees is 1/2. Okay? So 30 degrees would be the angle that we put into it. 1/2, the value is what we get out of it. Okay? And that works with all trig functions, even for the ones that are undefined. Okay? So we can put in the tangent of pi over 2. Okay? Pi over 2 is our input. Our output is undefined. It doesn't have a number, but it has a value, and that value is undefined. Okay? Refresh my memory, what does the y part of the ordered pair represent on a unit circle? Sine. Okay? That's a bad x. Actually, I shouldn't even say sine of x. That's right. We'll go sine of x. We should go sine of t there. Or actually, let's just even go sine of theta. Like that even more. Okay? X part of the ordered pair in the unit circle? That's cosine then of theta, right? Okay? I believe that is it for this one. So if I want to graph the sine function, now also remembering back to last unit in the obviosities section, what are all of my sine values in between? All sine values are in between two things. What's the smallest value that I can get out of a sine? -1. What's the biggest value I can get out of a sine? +1. So all sine values are going to be in between -1 and +1. Same with cosine. We learned that way back on the obviosities. Okay? All right? So knowing that, okay, so now if I want to graph my y equals sine of x, and my independent variable is now my angle, and my dependent variable is now a value that's going to be in between -1 and +1. Can't be outside of that because sine doesn't exist outside of that. How would I label my plane? So now, normally, we label our Cartesian coordinate system with x and with y. What would we now label it as? No. Which one's going to go where? So theta is going to go on my horizontal. So my inputs, my x values, are now going to be angles. And we're going to get out y values that will always be in between 1 and -1. So here's how we're going to go about doing that. Each of you has a two-sided white sheet that you picked up when you walked in. One side is labeled sine, one side is labeled cosine. You want to be on the sine side. Okay?
You want to go back like for 2 seconds?
No, not really.
Will you please? Just so I can see what I do.
So you're going to take your piece of spaghetti, and what you're going to do is down here underneath your graph, you have labeled, or you have a unit circle. Okay, so this is a unit circle. It is divided up into how many degrees? Oops, one too many L's. Circle-ly. What's it divided up into? What's it divided up into? 15-degree segments? No, it wasn't. Don't lie. How do I know that it's divided up into 15-degree segments?
90 divided by 6 is 15.
Because there's 6 segments in each one, right?
Yes.
Okay? Which means that there's 6, 12, 18, 24 total segments. 360 divided by 24 is 15. 60 or 90 divided by 6 is 15. Okay? So it's divided up into 15-degree segments. Is that important? Is that important?
Yes.
Why?
I don't know. I probably am going to need to know.
Okay. What you're going to do is you're going to take your piece of spaghetti. What are we graphing here? What are we graphing here? We graphing sine or we graphing cosine?
Sine.
We're graphing sine. Is sine x's or is sine y's?
Y.
Y. So what am I going to be graphing here? What am I going to be measuring with my piece of spaghetti?
Height. Y.
Y values, right? Okay, so I'm going to, now you've got one of two options that you could do here. You could take your piece of spaghetti and you could measure this distance. Oops, tap the brakes here. You could measure this distance. Oops. And you could break off that little chunk of spaghetti. Okay? One way of doing it. Another way of doing it is you could take your whole piece of spaghetti and you could bring it over here and you could either use your finger to measure it or you could make a little mark with your pencil on your piece of spaghetti. Okay? One of the two. I don't care how you go about doing that, but what you're going to do then is, come on, come back to that. So you're going to measure off of the you're going to measure the vertical where it hits on the circle. Then what you're going to do is you're going to take that measurement and you're going to go back up here to your graph and you're going to look for 15 degrees. Well, 15 degrees is right there. So you're going to measure out and put a dot at the end there. Got to measure it first. Did you put a dot then? You got to measure it first. Don't just put random dots. Okay?
I'm pretty sure I remember doing this last.
Now you're going to go all the way around your circle. What happens when you get to quadrant number 3?
Just upside down.
So where are you going to measure it on your graph? You're going to go into the negatives because it's negative values. Okay? All right? Give you time to measure it all the way around. Go. So it should have been there, then to there, then here, 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 there. So if you draw in, come on, here we go. If you draw in your curve, it should look like, oops. Should look like that. And this is called the first lap sine wave. It's called wave 1 because it looks like a wave. Okay. It's called sine because it's the sine function. We graphed y equals sine of x. And it's the first lap because we only went once around the unit circle. Right? Now, what would happen if we would go around a second time?
You would follow the curve.
It would follow the curve, but it would just be expanded out this towards me over here on the right side. Okay? If we went in the positive direction, right? If we went around a second time in the positive direction, we'd have another curve exactly like that, and third, fourth, fifth, etc. What if we went in the negative direction? Follow the same pattern?
Yeah.
Yeah, it would follow the same pattern even as our angles continue to grow in both positive and negative directions. Okay? We will typically only ever ask you to graph the first lap. Okay? This goes on forever in both directions. Okay, as evidenced here by, there it is. Okay, here is our sine function. It continues on in both directions, always never getting bigger than positive 1, never getting smaller than negative 1, and repeating that sinusoidal pattern all the way through. Okay. What I'd like you to do now is, I would like you to flip your page over. Now I want you to graph cosine. Now, instead of graphing sine where it was at, or where it was, we were looking for the vertical part, what are we graphing now? Cosine. So we're looking for the horizontal part. So we are measuring, again with your piece of spaghetti, we are measuring now this time off of the y-axis. Okay. So we would measure now here that way. Again, it's broken up into 15-degree segments. Okay? But now you're going to measure horizontally this time. Okay? Go for it. So in this one, you should have started here, and then
I don't know.
got to here. 90 is 0. 120. Yeah.
Oh, wait. Is it supposed to go? I don't know. Oh, wait, I might be
Did you see,
right.
Louise gonna be-
But this one's.
Oh, I didn't know. Like all
And it goes under a low line to something like that.
yeah, they're like hand in hand. County trees. What? The money don't take it.
It folds. Huh? Alright.
Wait, I went way too fast for that.
What? I didn't get that. I did not get that.
That's what you should have gotten. Because at 0 degrees, right? Straight out.
Yeah. I mean,
At 0 degrees straight out, you're at 1, right? So it should start up at 1. Because 0 degrees is at 1. And then you measure, you're always measuring off of the vertical, off the y-axis. So this would be the first lap cosine curve. Okay? And look at that. Just like that, Friday is over.
yes. Oh man. Time flies.